So now in this recording, we will try to understand the detection of heteroscedasticity, so there are broadly two ways by which you can detect this problem. The first one is basically a graphical analysis of the residuals, and we'll largely discuss this in this video. In the upcoming videos, we'll discuss these formal tests. So let us start with the first one, which is graphical analysis of residuals. So for graphical analysis, what do? We do is that uh, we simply plot the error square. Okay, we simply plot the error square on the y against the independent variable, that is the x variable. So but this is only applicable for a simple linear regression case, that is when there is only one independent variable in the regression. So what we do is that we plot we plot the error square. So remember that this is what we estimate, okay, and we basically look at, we find all the error terms and we square them, and we plot them against the independent variable. Now uh, if this graph shows any kind of a pattern, okay, if it shows some kind of pattern, then certainly there is some problem of heteroscedasticity, as we can see from case B, from case C, and D and E as well, that there is some pattern over here. This is almost like a parabola, and this is like, upward sloping line. It's almost same pattern is being observed here. And in this case we can see there is no pattern. What is really happening is that the error square is basically lying between two points, okay, between two, you can say this is some kind of a confidence interval, you can think of. It's lying basically in between them, but there is no strict pattern as such. So this is the case where homoscedasticity is, where we have homoscedastic errors, okay, homoscedastic errors. Rest all of them, B, C, D, E, they they point towards the problem of heteroscedasticity. So, but as I said, this is only for a simple linear regression case. If we have, let's say, if we are looking at a multiple linear regression problem, regression equation, in that such a case, it might become very tedious to draw these graph for all the independent variables, and it is also possible that it might show the heteroscedasticity in some cases, while it may not show in other cases. So we need more formal treatment here, and now we look at some formal tests that we can use to detect the problem of heteroscedasticity.